So for those of you who arrived late, there's the GitHub repo. It's under digital-asset/DerivHack2019. And over the next 30 minutes, we're going to show you one of the worked examples we have there, this Hello World example. There's a full README tutorial here, a lot of which I'm going to talk over in this session. So if you want to follow along, just have a look at that or clone the repo. But before we dive into that, I want to take a couple of minutes just to talk about the high-level architecture or the high-level design of the programs that I'm going to show you. So we're going to show you two different processes, both written in Python. The first one is going to take a CDM JSON file, which we've taken from the Regnosis website. In fact, it's the same one that Thomas just showed you a bit earlier. And we're going to upload that into a ledger using an HTTP-based API. So not shown on this diagram is a little HTTP server that sits in front of the ledger. And then I'm going to show you a second process, which doesn't use an HTTP-based API, but rather an internal Python API. And what that does is it sits and listens to events on the ledger, for instance, contract creations, and then reacts as a result of those contract creations. These are both written in Python, but in fact, as you can probably guess, the first one that I'm going to talk about could be any language that talks HTTP REST. And finally, what you see here, this blue cloud, is our cloud offering, which allows you to host a ledger and run automation processes. It's called Dabble. And that will be the topic of next week's seminar. So I'm not going to go deep into that in this session. And a final sort of warning for the guys who are more experienced and have already done some DAML programming. You might have looked at our official documents website, so docs.daml.com, and the official APIs that we provide there. And you should just be aware that we've specifically architected these examples to be able to sort of drag and drop them into the cloud deployment. So they don't use the same APIs that are advertised on our official website. So just be conscious of that when you're looking at these, and for the hackathon as well. So let me just reshare my screen and we could start looking at those programs. Okay, so first I'm just gonna check out the GitHub repo. And we're going to go into this Hello CDM example. And I'm just going to check out a version that I know works for this presentation. So in here, you're going to see the usual DAML directory structure. We've got a DAML folder that has our DAML model, which Thomas already introduced. We also have a Python directory that has the two processes I mentioned. And there's also a UI directory, which will be the topic of the last half an hour of this session. So I won't talk about that right now. And so what we're going to do is we're going to run this first main program. And like I said, what it's going to do is going to load up a CDM from JSON. It's going to use an HTTP API to load that into our ledger. And then it's going to read it back and exercise some choices on it. So in order to be able to do that, we need to actually bring up a local instance of a ledger, which we do with the daml sandbox command. But in fact, sorry, before we even do that, we need to compile the daml code. So let's do that, daml build. You're going to see a couple of warning messages there. That's just because we're including the whole CDM schema on there, but not using everything we import. But once that's done, then we should be able to start a sandbox ledger. And I want to bring your attention to a couple of the options I'm using here. So one is ledger ID, and that basically allows us to refer to this ledger in a specific way. And it's quite important during authentication, which I'll talk about in a moment. And the other one is static time, which we also need in order to be compatible with the cloud-based deployment. So you see the ledger ID here, and you see that we have loaded our CDM templates into the local ledger. Next, what we're going to do is start up an HTTP process. It's just basically an HTTP server that sits in front of the ledger and allows us to talk to it from the external world. In here, the important switch that I want you to observe is this max inbound message size, which you normally won't use, but because the CDM schema is so large, we need to use that to allow us to pass these large messages in. Otherwise, the contract creations will fail later on. So let's go ahead and start that. Okay, so I'm actually going to show you now the first script. I'm just going to run it, and then we'll explain what it's doing. And really quickly before that, we have to load up some dependencies. And we explicitly state this message integration library dependency, which I'll explain in a second why we need that. So let's actually run our example. Oh. We see a whole bunch of output there. We see it sending the contract to the ledger, reading it back, and exercising a choice. So let's have a look at the actual script to see what it's doing. I'm going to open that in a separate window here. So what the script does is it just executes 5 methods sequentially. And I'm going to talk you through those 5 methods now. The first one is very simple. It simply loads up a JSON CDM file, in this case, the cash transfer instance, into a Python dictionary and prints it out. So that's the first set of stuff that we saw here. And like I said before, this is an example we pulled from the Rignosis CDM website. There are some more there if you want to try them out. And the next function that we have here takes that Python dictionary, and it's going to do some conversions on it. Although both of the output dictionaries are JSON, there's some subtle differences in how the CDM encoding goes and how the DAML encoding for the HTTP API is. And the easiest way to explain that is just to look at an example. So what we showed here was the original CDM file. And I'm just going to look at the last 2 fields we have here. So we have timestamp, which is made up of a date time and a qualification field. And if we look at what the translator did, it's actually expanded this timestamp into 2 fields, including a time zone. And the qualification name has been mangled so that it has the enumeration name in it. And there are lots of small things like this in the JSON schema that prevent us from just loading it up directly. But we've provided you in this repo standalone Python library. That's what I loaded up with pipenv before, so that you don't have to do that yourselves. So if we look at how that's called, you just need to import this message integration library. You'll need to load up some metadata from a JSON file to specify a decoding strategy. And then you just call decode on that. And you also specify the type of CDM object you're decoding, in this case, an event. And if you want to do the opposite, it's very simple. You just do encode here instead of decode to bring you back in the opposite direction, which we're not going to do here. So then let's jump to the next function, which takes that converted JSON and actually uploads it into the ledger. It's quite a simple call. It just consists of a single call here. And this is actually the same for the next 3 methods. So it's just an HTTP post request using the requests Python library, where the first argument is the URI for the creation command. That's this here. And before providing the actual payload, there's a few things we need to add. So this comes back to what I mentioned when we started up the sandbox ledger. The first one is a security token that we pass here as a token header. And I'm just going to show you what that actually looks like. It's just a digest string you can see here. And I'm not actually going to explain in this particular session how to do that, but I'm going to refer you to the tutorial I mentioned. There's some links there explaining how you can generate these tokens. The important thing that you need to know is that that is a hash of something that includes the ledger ID, which we specified, excuse me here. So in this case, hello CDM. And so you cannot reuse those security tokens across different ledgers. And if you change your secret. But again, please refer to the tutorial to understand fully how to use that. The other thing which we need besides the payload or before producing the payload is a meta field in here that says ledger effective time. And we're essentially overriding the current time which the ledger uses to check that the creation requests are not stale. And this is something we do for the Dabble compatibility for being able to upload to the cloud. And that's also something that I think might change, but it will be discussed also in our next session when we talk more about uploading stuff into our cloud environment. So finally, the argument in here is the actual template we're generating. And you can see that we're passing the DAML dictionary, which we translated in the previous step. And what this returns is the HTTP request result. So we can see that right at the bottom here. We say sending transfer contract to ledger, and the response is HTTP 200 response. And then what we do after that is we read back the same contract from the ledger. That's in this read DAML JSON from ledger. And as I just said, it's very similar. This is actually even simpler than the previous call. Again, it's a post where we're providing the endpoint. We provide our token again, and we provide a filter for the type of templates that we want to get back. In this case, we're passing a cash transfer. Excuse me, is it transfer as the contract name? which in this particular example doesn't really matter because we only have one single type of contract, but you can imagine that in your CDM model, you might have transfers, executions, allocations, or whatever, and you only want specific type of contract back. So that's what this argument is for. And then we move on to the final method here, which is exercise choice. And that does essentially what Thomas already showed you, except it does it externally from an external process. And I'm just going to remind you really briefly what this does. So if we have a look at the actual JSON file, this cash transfer, you'll see somewhere further down we have, I believe, an identifier. Let's see if I can find it, or was it further up? I think it's this one here, the assign identifier. And so what we're going to do with this choice is in the ledger, we're going to overwrite the value with a hello message, and we're going to increment the version number. And again, it's the same pattern as before. We have the endpoint, headers, this meter field with the ledger time. But in this case, we have to specify the choice name, which is say hello, and the choice arguments, which in this case is going to be world. So we're going to say hello world. And that's what we've just executed here. So if you were to inspect the ledger at the moment, you'd see a cash transfer contract in there that says hello world in the ID and version number 2. Okay, so now we're going to turn to the second process. So let me just bring up the code for that. So that's the bot. And to remind you, this does not use the HTTP JSON API. It talks directly with the ledger through an internal API. And this can be hosted on the double cloud. So the way of working with this is slightly different. Instead of making RESTful requests, we have some callbacks. And in this specific case, we have an init callback, which is triggered when we're connected to the ledger and ready to consume contracts. And in our example, the only thing we're going to do is we're just going to say ready and listening for new transfer contracts. And then we have another callback, which is ledger created. And this is triggered every time a new contract is created. In this case, we specify that we only want to get transfer contracts. And what we're going to do when a new transfer contract is created is we're going to pull up the list of all active contracts, all active transfer contracts, excuse me. And we are also going to exercise the say hello choice on them. But this time, instead of changing them to say hello world, we're going to change them to say hello CDM. That's done over here. And so obviously there's some boilerplate to get this set up. And the last line that we call is this run forever line, which basically makes the program block and listen for those events that we specified before. So let's run this in a new window and actually see what happens. So run Python. It takes a little while to load up, about 15-20 seconds, because it loads the whole CDM schema. But we should soon see a message that says, I'm ready and waiting for contracts. There we go. So now let's create a new contract with the first script and see what happens. So I'm just going to run the same script I did before. And it looks like it worked. But when we look here, we can see that there's some sort of an exception that's being thrown. And if we really squint our eyes, we can see somewhere it says here, dependency error, couldn't find contracts, so-and-so. And this is actually expected. So if we think about what we're doing is we're running two processes concurrently, and they're both trying to exercise the new contracts that are appearing there. And as Thomas just explained to you, one way of getting around this is using contract keys. That solves this problem. But in this specific case, we're going to do something much simpler. We're just going to not exercise a choice from the first script. So let's look at the first script again, and I'm going to comment out this bit that says exercise contract. In fact, we're just going to quit the program early there. So let's try that one more time. And yeah, you see we're transferring the contract, sorry, creating the contract, reading it back, but we're not actually exercising it. And so if we look again at the output from the bot, we can see, that it's greeted us, greeting exercise choice on contract 6, hello CDM. And the reason that you see all those other ones, like I mentioned before, is because we're reading the entire contract list, not just the newest event that's appeared. So that's pretty much everything that I was going to show in this part of the tutorial. So just to recap, I've shown you two processes, one which loads up CDM contracts from the CDM JSON and translates them into a form that can be understood by the HTTP server that's spun up next to the ledger. And the second process is an automation process, which doesn't use the HTTP JSON API. It uses an internal Python API we call Dazzle, for which there's also more documentation again in the repo in the tutorial. And so I would suggest that if there are any bits that went too quickly or you didn't understand, that you refer back to the documentation, the tutorial that we've put together. Or if you have any other questions, you can raise them as issues on the repo and we'll have a look at them. So I don't know now if we've had some more questions in the meantime.
Yeah, there's two which we've answered, but I want to point them out maybe separately. So the first one is how do parties share data with each other and come to an agreement? Is it through the CDM JSON file? So the sharing of data on a demo ledger is primarily done via the observer keyword. So whenever you create a contract, you can put any party you would want to see this contract as an observer on that contract. And that basically discloses the contract so the other party can see it. And then in terms of interaction and how to come to an agreement, that would then be done via choices. So that's the second question. Is an observer allowed to execute transactions choices on a shared contract? So yes, you can then declare the controller for a choice, and for example, use the observer that you've put in on the contract, and then this party is allowed to exercise that choice. And to also mention how you would then sort of come to an agreement. So what Levente has shown last time is basically that a typical pattern how you get multiple parties as signatories onto a contract would be, for example, to first propose a contract from one party where you have the first party as a signatory and give the other party the choice to accept it. And in that choice, you would create the new contract that has both signatories. So that's basically the pattern how you collect signatures in demo. There's one more question. What builders for events have been written and are available to use in the code? So the builder function that Thomas showed earlier was just an example of how you would create a CDM event in DAML. I would expect at the hackathon that most of the CDM that you're dealing with is actually sort of provided to you when you load it onto the ledger. And for those cases where you would have to produce then CDM off the ledger, you would have to write your own builder. But you can take the example that Thomas has shown as a sort of as a starting point and then just adopt it to whatever type you'll have to create. And maybe to add to that, so these builders, they typically are very simple functions that just take a couple of arguments and then default most of the CDM fields except the arguments that you want to set.
I can see here someone's asking, do you have a Dockerized ledger image available? We might have one somewhere. We don't have one as part of this repo, but we'll make note of that. We might be able to provide something for the hackathon, but we can't promise anything right now.
So there is a doc image for the DAML SDK, which I've posted the link, but we don't have one for the repository that we just showed you. Another question came in: if we need 10 parties to sign a contract, can one propose and other 9 accept the offer asynchronously, and they would get added cumulatively till all 10 are available? So you couldn't do that on a single contract, but there is a pattern to collect these signatures. In fact, you can do it on a single contract. There's a pattern related to that, and I think we have an example of that in the documentation, if I'm not mistaken. It's called something like multi-party agreement, and we can probably look it up and provide the link later.
So I guess the short answer is yes, it's possible.
Yeah.
So you can collect acceptances asynchronously. So the one party proposes, all other party asynchronous accepts, and then the proposer party needs to collect those acceptances to build up a multi-party acceptance contract.
Yeah, that's correct. And I see just the multi-party agreement in the docs, I think, is sort of the synchronous way where you have a single contract, which then people one after the other sign. So that's another way of collecting signatures. There's another question regarding CDM being a tool built by ISTA using DAML and how relevant it is. Well, that's a bit difficult to say. So CDM is not built by ISTA using DAML, but we have built a DAML library to support the ISTA schema. And the question of how relevant is to different use cases, I can't really answer. I can give you my opinion. I mean, there's a lot of industry demand coming from the financial sector. You know, CDM being somewhat of a spiritual successor to FPML, which has been widely successful. There's a lot of interest in adopting the standard.